But first I should formulate LPP. Now let us formulate LPP from the table. Now you should substitute the corner point in objective function, that you put it in Z. So they have given Z. What is the value of Z? Or region which is determined by all the constants including non-negative constant is called as feasible region. So now vertices of feasible region are called as what? Corner points. An objective function means what? A function which we need to maximize and minimize. All are given in minutes. This is in minutes, this is in minutes, but this is in hours. Welcome to the session, dear students. Today we'll go ahead with the problems of linear programming problems. See, in today's class, word problem. First we have to read the words, whatever is given, convert them into a LPP. First we should formulate LPP. So earlier they directly used to give the equations. You need to solve it, but here you should create a linear programming problem after reading the situation given. So now first let us formulate LPP. A manufacturing company makes two models, A and B, of a product. Each piece of model A requires 9 labor hours for fabricating and 1 labor hour for finishing. Each piece of model B requires 12 labor hour for fabricating and 3 labor hour for finishing. So for fabricating and finishing, the maximum labor hours available are 180 and 30 respectively. The company makes a profit of rupees 8,000 for each piece of model A and rupees 12,000 on each piece of model B. How many pieces of model A and B should be manufactured per week to realize a maximum profit? So what is the maximum profit per week? So now this situation, we need to convert it into linear programming problem. First, when you read, we'll get an idea that this is a manufacturing case. So what you should do, make a table. First, resources. What are the resources? And type of products. What are the type of products? So we produced model A and model B. And then we have availability of the resource. So make 3 columns and convert the problem to a table. Then it will become easy for you to convert it into equations. Now I'm drawing a table. So first I analyze that the given problem is a manufacturing problem. For the manufacturing problem, first our task is to convert the situation to what? Convert the given situation to what? Table. So now 2 models, model A and model B, they are producing, and the resources, one is for fabricating, they're spending some time, and finishing. So for fabricating, and the other we are using finishing. So now first, how many units of A and B are required to be produced? They are asking how many pieces of A and B should be produced is the question. So first beginning we'll assume let X pieces of A and Y pieces of B be produced. This is our assumption. So I'm producing A X pieces, B Y pieces. So now to produce A, we need fabricating time as well as finishing time. So first we'll fill A. A requires 9 labor hours for fabricating. So in fabricating I'll fill A 9 hours. And for finishing, 1 labor hour for finishing. So this is 9 labor hour for fabricating, 1 labor hour for finishing for type A. Similarly, they have also given for type B. When you further read the question, type B requires 12 labor hour for fabricating, 3 labor hour for finishing. 12 labor hour for fabricating and 3 labor hour for finishing. So this is for type B. Availability. Now we'll say time availability of fabricating and finishing. Availability, when you read, so the company makes a profit of 8,000 for each piece of model A and 12,000. And when they told for fabricating and finishing, maximum labor hours available are 180 and 30. 180 and 30 means 180 for fabricating and 30 hours for finishing. So for fabricating, they provide 180, and for finishing, they are providing, what is the time given? 30 hours. So now profit also they have given. They have also given profit. So profit for both the cases. So profit for A, one piece of A produces, what is the profit on A? So when you read, so each piece, see the company makes a profit of 8,000 on each piece of A and 12,000 on each piece of B. So for A, 8,000 is the profit and B, 12,000 is the profit. Dear students, whatever they give, I converted into table. But first I should formulate LPP. Now let us formulate LPP from the table. So when you read the question, they want what is the maximum profit. So you should maximize the profit. So maximize what? Profit. Maximize profit. Because they want you to maximize the profit. So maximize Z is equal to, all of you know, an objective function means what? A function which we need to maximize and minimize. First we'll write objective function. I need to maximize the profit. What is the profit? So when you read the question, profit you'll get 8,000 for A if you produce 1 unit. But you are producing how many units of A? X units. So for producing A gives you 8,000 into X. Because 1 unit of A gives you 8,000 rupees profit. That's what they gave. I am producing X units. So I'll get total 8,000 into X as profit due to A. And we are also producing B. B gives you how much after selling B? You'll get 12,000 rupees profit for one piece. But we are producing Y pieces. So total profit is 12,000 into Y is the profit of Y. So this is the maximize. We need to maximize this. We need to maximize profit. This is a profit function. So any linear programming problem should contain objective function. I wrote it. Now subject to conditions, constants. The first constant is machine A is available only for 180 hours. So means what? 9 hours for one piece of A. So we are producing X. So 9X and 12Y put together should not be more than 180. So 9X plus 12Y should be less than or equal to 180. Further, these are divisible by 3. You can also reduce this equation. Later that implies if I divide by 3, all are divisible by 3. Divide by 3, it gives you 3x plus 4y less than or equal to 60. I reduce the equation because all are divisible by 3. I divide them by 3. So the first constant is 3x plus 4y less than or equal to 60. And the basic is 9x plus 12y should be less than or equal to 180. Or when you divide both sides by 3, because all are divisible, 3x plus 4y should be less than or equal to 60. Then other constant is finishing. So 1x plus 3y. This is 1x and this is 3 times y should be less than or equal to 30. The other one is x plus 3y less than or equal to 30. This is in standard form. So x plus 3y less than or equal to 30. So we got two constants. After you get two constants, the third one is number of pieces produced. X is number of pieces of A and Y is number of pieces of B. Number of pieces produced cannot be negative. So X should be greater than or equal to 0 and Y also should be greater than or equal to 0. So these are the three cases. So these are the three constants. So you should solve these two constants. And now see, given situation, this was a given situation. We converted into what? A LPP, linear programming problem. We should maximize Z is equal to 8,000 plus 12,000 subject to the conditions 3x plus 4y less than or equal to 60, x plus 3y less than or equal to 30 and xy greater than or equal to 0. So that's what I have written. So 9x plus 12y less than or equal to 80 divide by 3, you will get this. This is one condition and this is second condition. Draw the graph for these two and you need to maximize this. I hope all of you understood this. So now our task is to maximize the profit. In order to maximize the profit, we will solve it graphically. So let us graph it. So first line, what is the first line? 3x plus 4y less than or equal to 60. 3x plus 4y less than or equal to 60. So put x is equal to 0, you will get 4y is equal to 60. y is equal to what? 60 by 4. 60 by 4 is what? 4 ones are 4 5s are 15. So one of the point is x is 0, y is 15, 0 comma 15. So put a point 0 comma 15. This is 0 comma 15 is a point on what axis? Y axis. This is point, one of the point, you can name it A. Then put y equal to 0. If you want a line, we need minimum 2 points, 1 point on y axis, 1 point on x axis. So put y 0. If you put y 0, 3x will become equal to 60 and x will become 60 by 3. 60 by 3 is what? 20. The point is 20 comma 0. 20 comma 0 is another point here. So point here. This is 20 comma 0. So now first line will get, I'm using red color to draw this. This is the first line. Now our task is to shade this line. In order to shade, they told less than or equal to. Generally less than means what? Shade towards origin, shade below. Shading comes below. Shading goes like this, but you should not go away from the first quadrant because the shading lies within what quadrant? First quadrant, because x and y both are greater than or equal to 0. Non-negative constraints are there. Okay. So now I've drawn one line and I've shaded the one line. I use the red color to represent the first line. This is my first line between 2 points A and B, and the shading of the line is also done. So shading of the line goes down like this. Now second line. What is the second line? Second line is second constraint. So we have done with first constraint. So x plus 3y less than or equal to 30. X plus 3y less than or equal to 30. Let me use other color. So x plus 3y less than or equal to 30, or x plus 3y equal to 30, and put x 0. If you put x 0, 3y becomes 30, y becomes 10. So point on x axis 0 comma, point on y axis 0 comma 10. So this is 0 comma 10, we call it a C. 0 comma 10 here I have mentioned. So 0 comma 10, and another value, put y 0. If you put y 0, x will become 30. So 30 comma 0 is another point, that is 30 comma 0. This is 30 comma 0. I call it as D. Now stretch a line between C and D. This is the second line. Second line between CD. Now you have to shade again less than or equal to. So shade what? Below. Shade below. After you shade, retain the common region. Common region of shading is called as feasible region, or region which is determined by all the constants including non-negative constant is called as feasible region. So now whichever is feasible, whichever is common, retain it, uncommon, erase it. So here in between these two it is uncommon, so erase it. Between these two it is uncommon, erase it. So now here shading mixes, so retain this. This is feasible region. So this is what? Feasible region. So I call this as what? Feasible region. What is a feasible region? Feasible region where both purple line as well as red line mix, means the region where it's common for both the shading, that is feasible region. We got feasible region. So vertices of feasible region, one is O, the other one is C, the other one is B, point of intersection. So if you draw perpendicular, you'll get point of intersection. The other one is B. So these are vertices of feasible region. Whatever I circled, they are the vertices of feasible region. Vertices of feasible region are called as what? Corner points. Now you draw the table, corner points. So one corner point is 0, 0. We have drawn it. And the other corner point is 0, 10. So here we have 0, 10 also. And the other corner point is what? 12, 6. So 12, 6. And the last corner point 20, 0. Vertices of feasible region are corner points. Now you should substitute the corner point in objective function, that you put it in Z. So they have given Z. What is the value of Z they give? When you read the problem, it is 8000x plus 12000y. So now substitute each point. So for example, if you put x and y 0, 0. So here 0, here and 0. If you substitute 0 into anything is 0. So 0 plus 0 becomes 0. So Z becomes 0. Second 20 comma 0. 20 comma 0 means what? In the place of x you put 0, in the place of y you put 0. So say in the place of x put 20, it will become 8,000 into 20 plus 12,000 into 0. So now this will become 1,60,000, and this is the value. So 1,60,000 we'll get. Similarly, put 12,6 in the place of x put 12, in the place of y put 6, and you'll get 1,60,000. 1,68,000. 0, 10 you put, you will get 12,000. They want you to maximize. In the table, which is the maximum value, 1,68,000 is the highest value out of all the entries. So therefore, maximum profit we'll get when you produce. Maximum value of the profit is 1,68,000 occurs at 12,6, means maximum profit you will get by producing 12 units of type A or model A and 6 units of model B. By producing 12 units of model A and 6 units of model B, you will get a maximum profit of 1,68,000. So this is the conclusion. So I hope all of you understood. First, read the problem, convert it into linear programming problem, that is formulate. After we formulate, solve it graphically. So similarly, one more problem, which is again manufacturing. A factory manufactures two types of screws. One is A and the other one is B. Each type of screw requires the use of two machines, automatic machine and hand operated machine. So resources, automatic machine and hand operated machine. It takes 4 minutes on automatic machine and 6 minutes on hand operated machine to produce a package of A. Similarly, while it takes, they mention 6, and while it takes say 6 minutes on automatic and 3 minutes on hand operated to produce a package or to manufacture a package of B. Now each machine is available for at most 4 hours on a day, and the manufacturer can sell a package of screw at a profit of 7. Profit they give 7 rupees, and for package of A, and he'll get a profit of 10 rupees on package of B. Assume that he can sell all the screws he manufactures. How many packages of each type should the factory owner produce so that in order to maximize his profit? Again, they wanted to maximize his profit. Determine the maximum profit. Similar to the last problem, this is also a case of manufacturing problem. I told you, make a table. So where the table should contain resource. Apart from resource, types. So here we have types. What are the types? Screws and types of goods. Screws and bolts. Sorry, screws, package A and package B. That's what is given, right? So package A and package B, type of screws, type and availability. So make it and solve this graphically like last situation. So now resources, one is automatic machine. Automatic machine. This is one resource, and the other one is hand operated machine, HOM, I'll write. Okay, so these are the resources, and also they give profit per package of A and per pack of B. So now convert this situation to table and convert the table to what? So now I made a table. Now convert this table to what? To a linear programming problem. So now we'll do the entries of the table. What are the entries of the table? So each type of screw uses both the machines, automatic as well as hand operated, and it takes 4 minutes on automatic and 6 minutes on hand operated to produce A. So first we'll assume let X packages of A and Y packages of B are produced. B are produced is our assumption. Now coming to this, so A is X, B is Y. Now fill the table. So A requires what? When you read the question, automatic, so it takes 4 minutes on automatic and 6 minutes on hand operated for A. For A, 4 minutes and 6 minutes. For B, it takes 6 minutes and 3 minutes. 6 minutes on A and 3 minutes on B. And profit on A, profit on B is also given. What is profit on A and profit on B? 10 rupees and 7 rupees and 10 rupees. And also they gave maximum availability of the machines. So they told here clearly 4 hours a day. So each machine is available 4 hours, not more than 4 hours. That's it. So now they want you to maximize the profit. So Z is profit now. So for one package of A, you are getting 7 rupees. You are producing X. 7X is the profit on A, and 10 rupees you will get for package of B. So you are producing Y. So 10Y is the profit on B. This is the total profit subject to conditions. What are the conditions? 4x plus 6y. 4x plus 6y should be less than or equal to 4 because machines are not available more than 4 hours. And next one is 6x plus 3y less than or equal to 4. So these are the things. And X number of packages should be always greater than or equal to 0. In any problem, we are getting this non-negative constant. Now you know how to draw the graph. So take the first line. And so this is how you can formulate, and I'm making them same. 4 hours into minutes, I'm covering 4 hours into minutes if you cover, so 60 minutes. So because all other things, see here, all are given in minutes. This is in minutes, this is in minutes, but this is in hours. So that's why to make them in hours, so multiply 60, don't forget. So now the equality, linear inequality will be like this. 6x plus 3y less than or equal to 240, and all are divisible by 3, divide them by 3, so you'll get this as first equality. And second one also, so all are divisible by 4, divide them by 4, you'll get this. So now draw this line and draw this line and shade it, you'll get a graph like this, and find the feasible region. So this is the feasible region, and afterwards corner points, and substitute them in Z, you'll get Z maximum value as 400, and Z is equal to 400 is a maximum occurs when you produce 30 packets of A and 20 packets of B. So graphing is similar to the last case. So here nothing to explain more because so you are thorough. If you are thorough or if you understood the first problem, this is similar. So shading for both will mix here. Hope all of you got this. Please take scale pencil and first formulate, then you convert it. So draw all the graphs, and I'll see you in my next session. Thanks for attending. Thank you.